In this video, I explain about mathematical expectation. The other name of mathematical expectation is mean value of the random variable. So we have two types of data, the discrete random variable and the continuous random variable. We discuss mathematical expectation for both discrete and continuous random variables separately. For discrete random variable, suppose your variable x is discrete and finite sample space. The results of your experiment is finite and with point probability, which is represented by x. So the mean value, which is denoted by expected value of x, is defined as random variable x multiplied by f of x, which is the probability of the random variable, and then the sum, and operate this procedure for complete sample space. In your sample space, if you have 5 values, then for each random variable, calculate its probability, multiply with probability, and then sum. You can find expected value of x for the discrete random variable. In next slide, we solve it for an with the help of an example. For continuous random variable, for continuous random variable, its PDF is represented for continuous distribution. Their PDF represented by probability density function. So we called it as density function f of the mean value is expected value of x. For continuous distribution, the sign is integral because discrete random variable is countable. So we can sum, the summation sign is used. And in continuous variable also includes the values of points. So this is represented by integral, and rest of the procedure is same. Multiply each variable x to its probability and then take its integral. You can calculate expected value of x. But remember that if your limit is approaches to infinity, then your expectation does not exist, because the series is divergent, and in case of divergent series, your expectation is not exist. So it is your limit of integral will be less than infinity. So here we discuss the example. Suppose two coins are tossed 16 times and x represent the number of head appear. Because two outcomes in case of coin tossing, one is head and other is tail, and your probability of success, or your considered variable x, is represented by number of heads appear on the dice. Suppose that x takes value 0 means no head appear, 1 means one head appear, and 2 means two head appear. So our random variable x constitutes 0, 1, and 2. So suppose that experiment yields no head, one head, two head have the 4, 7, and 5 probabilities respectively. So take its relative. For as you know, by definition of probability, outcome of interest divided by total outcome. So 4 divided by total outcome 16, 4 by 16, and multiply by its random variable, which is 0, and 7 appear for 1 multiply by f of x, where f of x is outcome of interest, which is 7, divided by total outcome, which is 16. The basic definition of probability is p of x is equal to outcome of interest and divided by total number of outcome. So for third random variable is 2, and outcome of interest is 5, divided by total outcome, which is 16. So this is f of x represented the probability. So add up, we have 1.06, which is the mathematical expectation. So here is again the explanation of the previous example that we solved. The number 4 by 16, 7 by 16 and 5 by 16 are the fraction of the toss of resulting, because as I said previous slide, outcome of interest divided by total outcome is the according to the definition of probability. So these fraction are the relative frequency for different random variable of x, or the relative frequencies are the we called it as probability p of x. It is also represented by p of x or f of x. So we calculate the mean and average. And let us now this method of relative frequency to calculate an average number of head per toss of two coins that are expected in the long run. So this is the description or explanation of the previous slide. And the important point is that if the your sample space is countable and the series is divergent, if your series is divergent mean the series or sequence does not have any finite limit, means your series has not finite limit, then the mean value of x does not exist. Thanks for watching. Please subscribe my channel Statisticians Club and like this video. If you want to see videos about MCQs of probability distribution, then click the link in front of your screen. Thanks for watching.